Hello everyone, I am Nivedita Jana from Ambika Prasad Research Foundation. Welcome to all of you to our channel Biodiversity and Conservation. So today in this part we are going to learn about the hydrological cycle, water as a universal solvent, the DO, DOD, COD, coagulation and flocculation, etc. So let's start. First one is the hydrological cycle. So, what is hydrological cycle? It defines the hydrologic cycle involves the continuous circulation of water in the Earth atmosphere system. At its core, the water cycle is the motion of the water from the ground to the atmosphere and back again. Of the many processes involved in the hydrologic cycle, the most important are evaporation, transpiration, condensation, precipitation, and runoff. So the evaporation is the change of state in a substance from a liquid to a gas. For evaporation to take place, energy is required. The energy can come from any source, like the sun, the atmosphere, the earth, or objects on the earth, such as humans. Transpiration is the evaporation of water from plants through stomata. Stomata are small openings found on the underside of leaves that are connected to vascular plant tissues. In most plants, transpiration is a passive process largely controlled by the humidity of the atmosphere and the moisture content of the soil. Of the transpired water passing through a plant, only 1% is used in the growth process of the plant. The remaining 99% is passed into the atmosphere. Condensation is the process whereby water vapor is changed into a liquid state. In the atmosphere, condensation may appear as clouds or dew. This is also the process whereby water appears on the side of an uninsulated cold drink can or bottle. And it is not a matter of one particular temperature, but of a difference between two temperatures, the air temperature and the dew point temperature. The dew point is the temperature at which dew can form, and it is the point at which air becomes saturated and cannot hold any more water vapor. Any additional cooling causes water vapor to condense. Foggy conditions often occur when air temperature and dew point are equal. Precipitation results when tiny condensation particles, through collision and coalescence, grow too large for the rising air to support, and thus fall to the earth. And precipitation can be in the form of rain, hail, snow, or sleet. Runoff occurs when there is excessive precipitation and the ground is saturated. Rivers and lakes are results of runoff. Some runoff evaporates into the atmosphere, but most water in rivers and lakes returns to the oceans. And evaporation of this runoff into the atmosphere begins with the hydrologic cycle over again. Some of the water percolates into the soil and into the ground, water only to be drawn into plants again for transpiration to take place. So water is called a universal solvent because water can dissolve much more substances than any other liquid found in nature, but water cannot dissolve every substance. For example, water cannot dissolve fats, waxes, and hydroxides due to the low solubility of oppositely charged particles. And reasons for the solvency of water are: water molecules consist of a polar arrangement of hydrogen and oxygen atom. Hydrogen present on one side has a positive charge while the oxygen atom carries a negative charge. These charges help the water molecule to bind to different types of molecules. Concept of DO, DOD, and COD. So the DO is stand for dissolved oxygen. Amount of oxygen dissolved in a body of water, such as lake, river, or stream, is known as dissolved oxygen, and this is the indicator of water pollution. The DO levels in natural and wastewater depend on physical, chemical, and biological activities in water body. The amount of oxygen that can be dissolved in water by temperature. It is usually determined by a Winkler's method, known as iodometric method, and this method was developed by L. W. Winkler, a Hungarian chemist, in 1888. The basic principle of this method is that DO reacts with manganese ions to form manganese dioxide, which further reacts with iodine ion to liberate in an amount chemically equivalent to the original dissolved oxygen. Then the BOD, which stands for biological oxygen demand. The biological oxygen demand is the amount of dissolved oxygen required to break down the organic material of the sample by aerobic biological microorganisms at certain temperature over a specific period of time. This parameter is determined with the consumption of oxygen by microorganisms during 5 days of incubation at 20 degrees Celsius. The BOD indicates a amount of pollution of water body. Lower BOD indicates the water is a good quality for aquatic life or little aerobic activity, whereas the higher BOD indicates the water is highly polluted. When BOD is higher, then DO becomes lower. So aquatic organisms are unable to survive at normal rate. It becomes stressed, asphyxiate, and may die. Then the COD, which stands for chemical oxygen demand. The COD is an empiric laboratory assay which measures the amount of organic matter contained in a water sample with the help of chemical oxidizing agents such as potassium dichromate and potassium permanganate. COD is a means of measuring all organic matter which is biodegradable and non-biodegradable. This test is useful in study of pollution strength of domestic and wastewater. COD values are greater than BOD values. The open reflux method is suitable for a wide range of wastes. Um, like the basic principle, the organic matter gets oxidized completely by K2Cr2O7 and silver sulfate catalyst in the presence of sulfuric acid to produce carbon dioxide and water. The excess K2Cr2O7 remaining after the reaction is titrated with FeNH4 whole bracket 2 and disulfate. The dichromate consumed gives the oxygen required for oxidation of the organic matter. So what is sedimentation? Sedimentation is the tendency for particles in suspense to settle out of the fluid in which they are entrained and come to rest against a barrier. This is due to their motion through the fluid in response to the forces acting on them. These forces can be due to gravity, centrifugal acceleration, or electromagnetism. And the purpose of sedimentation is to enhance the filtration process by removing particulates, and it is the process by which suspended particles are removed from the water by means of gravity or separation. Then what is coagulation? When water is turbid due to the presence of such fine size and colloidal impurities, plain sedimentation is of no use, and coagulation, a chemical process which removes all fine size and colloidal impurities within reasonable period of 2 to 3 hours. The coagulant is the chemical used in the process. The objective of coagulation is to unite several colloidal particles together to form bigger sized settable blocks which may settle down in the tank. And it is the process of adding chemicals to water to make dissolved and suspended particles bind together and form larger particles that settle out of the water. Then coming to the flocculation. So flocculation is a process by which a chemical coagulant added to the water acts to facilitate bonding between particles, creating larger aggregates which are easier to separate. The method is widely used in water treatment plants and can also be applied to sample processing for monitoring applications. In colloid chemistry, flocculation refers to the process by which fine particulates are caused to clump together into flux. The flux may then float to the top of the liquid, settle to the bottom of the liquid, or be readily filtered from the liquid. So that's it all for this part. Thank you.